Hello friends, so in today's question, find out the acceleration of the blocks and find out the tension in the string. So this is a first part. So you have two blocks 5 kg and 10 kg and the coefficient of friction is given as 0.5 and they are interconnected by a single string, and we are going to find out the acceleration. So in this case there is one standard, you can say, approach which usually helps in solving this type of question. Okay, so in that case what we do, we consider the acceleration of the system without the friction. Okay, what we do, we consider the acceleration of the system without friction and 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 use same value of acceleration and use same value of acceleration with friction. Same value of acceleration with friction. It means if I consider that A is the acceleration of 5 kg without friction, then with friction also I am going to consider the value of A, value of acceleration for 5 kg as A. Okay. So there are two possibilities then, okay, that the acceleration can be positive and acceleration can be negative. So we can say that if the acceleration is positive, then our assumption is true. Then the assumption or consideration is true, and if the acceleration is negative, then we can say the system is at rest. Then the system is at rest. This is the two points, important points, which we are going to consider in solving these type of question which involve the string as well as friction. Okay. So let us start with question A, and it is given that there is a 5 kg and there is 10 kg block and friction is 0.5. So let us say that there is a tension T here as well as T here, and we assume that without friction it is moving towards the right with A, and block number 10 kg is coming down with the acceleration A. So we say that without friction 5 kg block moves toward right excuse me, towards right with the acceleration A and 10 kg block, move downward with acceleration, A. So it means with friction also it will be same. You can see that with friction then with friction acceleration of 5 kg will be A, and that will be toward right, and acceleration of 10 kg is also A, and that is in downward direction. Downward. So there will be a mg that will be acting downward, which will be over 100 Newton, and we have here as 50 Newton. There will be a normal acting in upward direction n, whose value will be equal to 50 Newton, and here we are going to have Fr, which will be equal to mu into normal, and we get this is 0.5 into normal is 50, so this will be equal to 25 Newton. So let us draw the free body diagram for 10 kg now. Okay, that for block 10 kg, this 10 kg downward acting as 100 Newton, moving also in downward direction as A. Upward we are saying that is a tension of T. So we can write the equation as 100 minus T will be equal to 10A. Let this be equation number 1. Now for block 5 kg, block of 5 kg, is 5 kg block, we have a tension T, and here we have Fr, whose value is 25, and we have acceleration A towards right. So we can write the equation as T minus 25 is equal to 5 multiplied by A. From here we can say that our T is equal to 25 plus 5A, equation 2. Using equation 2 first and second, using equation 1 and 2, we get 100 minus 25 plus 5A is equal to 10A, and the solution can be written as 100 minus 25 minus 5A is equal to 10A, which gives us 75 is equal to 15a, and acceleration A will be equal to 75 divided by 15, which says that acceleration A will be over 5 meter per second square. And we check the sign. So A is our positive. So if A is positive, it means the assumption which we made is correct. Okay, we write it here. This means our assumption of direction of A is correct. And now we are going to find out our T. So we put this value of A in the equation 2. We write from equation 2 we get T is equal to 25 plus 5 into 5, which is nothing but 50 Newton. So we get tension as 50 Newton, and acceleration is of both the blocks is 5 meter per second square. Now we have second question, same things. We have B part, and in this B part, once again this angle is given as 53 degree, coefficient of friction is 0.1, and it is on inclined plane of 2 kg, and hanging weight is also 2 kg. So we have tension T here, and there will be 20 Newton in the downward direction, and we assume that 2 kg is going up with the acceleration A, so this 2 kg will be coming down with the acceleration A. And here we are going to have 20 Newton, and we can divide this into two components. This will be our normal, this will be 53 degree, so this, and there will be two components. Okay, let me draw it here. So we have this as 20, 53, and this will be our 20 cos of 53, which will be coming as 12 Newton, and this will be 20 sine of 53, and this will be coming as 16 Newton. Okay. So once again we assume that without friction, say without friction, without friction 2 kg, without friction the acceleration of 2 kg is A up the incline, and let us, for simplicity, let us call this as block 1, and let us call this a block 2. Okay. So here I am talking about block 2. Is up the incline, and of block 1, which is also 2 kg, is A downward. And now we are going to consider the friction, but we are going to stick with our same acceleration. Okay. So we say also with friction, we have block 1, that is 2 kg, having acceleration of A up the incline, and block 2, which is also 2 kg, is having acceleration A downward. Now let us draw the free body diagram of block number 1. Okay. So we say for block 1, this is 2 having force of 20 Newton, moving downward with acceleration A, and there is tension T in upward direction. So we can formulate the equation as 20 minus T will equal to 2A. Let us call this equation number 1. And now if we formulate the equation for block 2, okay. So block 2, we have T, so this is our block 2, 2 kg, up the incline is T, down the incline is 16, and there is a friction Fr. Okay, there is a friction of Fr. So we can say T, and there is acceleration upward A. So this can be written T minus 16 and minus Fr, and Fr 0.1 into normal, that is 12. Okay. So let me write here, Fr is equal to 0.1 into 12, so this will be coming as 1.2. 1.2 is equal to 2A. So this is equation number 2. So using equation 1 and 2, using equation 1 and 2, we can say 20 minus T will be equal to T minus 16 minus 1.2. So we get this as 2T will be equal to, this will be 20 plus 16 plus 1 by 2, so this comes as 37.2. From here we can say T is equal to 37.2 divided by 2. This is our tension T, and we can use any one of the equation. Let us put in equation 1. Okay. So we can say that from equation 1 we get 20 minus 37.2 divided by 2 is equal to 2A, or we can say from here 2A will be equal to 1 second, let me check. Yeah, I think so. Okay. we have 40 minus 37 by 2 divided by 2, and A will be coming as, I think, 40.0, 37.2, this will be 8, and we are going to have 9, and this will be 2.8 divided by 4, and the acceleration is positive, so we can say that our assumption is correct of direction. Our assumption is correct. This gives us the acceleration as well as tension. Next question. So this is the figure, and in this case also we are going to find out what will be the acceleration as well as we are going to find out. So this is our a movable pulley which is connected to 4 kg, okay, and this is our pulley which is connected to 2 kg, and the coefficient of friction here is given as 0.4, and we are going to find out what will be tension as well as what will be the acceleration. Okay. So let us assume that it is moving in downward direction with the acceleration a1, moving towards left with the acceleration of a2. Coefficient of friction is given as 0.4. This is 2 kg. Okay, so we have here as 40 Newton. Let us say tension is T. Here it will be also T, and here it will be now 2T. Okay, so this is T, so obviously this will be once again T. And here we are going to have a force of 20, and upward there will be a normal whose value will be equal to 20. And let us suppose here the friction is given as Fr. So let us draw the free body diagram for 4 kg. You can say that for 4 kg we have 40 minus 2t, and there will be acceleration of a1 in the downward direction, that is for a1. Okay, let us call this equation number 1. Now for 2 kg, okay, you can draw it here. This is 2, we have a tension T, and there is a friction Fr which will be equal to 0.4 into 20, which will be our 8 Newton. And it is given acceleration of A2. So we have here T minus 8 will be equal to 2A2. Now we are going to find out, this is question number 2. Now we are going to find out the constraint relationship between A1 and A2. Okay, so let us call this as point 1, this is point 2, 3, 4, and this point is called as 5. And let us find out what will be the acceleration of the respective. So we can say that point 1 is fixed, so its acceleration will be equal to 0. Okay, we can say point 1 is fixed, therefore its acceleration is equal to 0. Now we come to point 2. Point 2 is moving in downward direction. There is increase in length of the string between 1 and 2. Okay, point 2 is moving in downward direction, and the length of the string between 1 and 2 increases. Therefore, its acceleration, is equal to positive A1. And similarly is for point 3 also. Similarly for point 3, acceleration is plus A1, and point 4 is fixed. Okay, you can say point 4 acceleration is 0, and we are left with only point 5. Point 5, there is decrease in the length of the string. Okay, point 5, the length of the string decreases. Therefore, acceleration is equal to minus of A2. Okay. Now we add all the accelerations, and that will be equal to 0. We have 0 plus A1 plus A1 plus 0 minus A2 is equal to 0. From here we can say twice A1 is equal to A2. This is the constraint relationship between A1 and A2. Okay. Now we can make use of all the equations, and this is our third equation. So let me write all the equations here once again. We have 40 minus 2t is equal to 4a1, and we have t minus 8 is equal to 2a2. So what we do, we substitute value of t from, this was our equation 1 and this was equation 2. Okay. So we get 40 minus 2 and here it will be equal to let me do it other way. We can say that t minus 8 is equal to 2 into substitute value of a2, that is twice a1, which is equal to 4 times a1. Okay. So now it is much more easier to solve. We can say that our (40 minus 2t) is equal to 4a1, and we have t minus 8 is also equal to 4a1. So we can say from here 40 minus 2t is equal to t minus 8, and we say 40 plus 8 is equal to t plus 2t, which is equal to 3t, and t will be equal to 48 divided by 3. Okay. So we get the value of t, and we can find out value of a1 also. Okay. So let us use this equation. T minus 8 is equal to 4a1. So putting value of t, that is 48 divided by 3. We can cancel it. 16 Newton. So we get this as 16 minus 8 divided by 4 is equal to a1. a1 is equal to 8 divided by 4, which is equal to 2. So we have a1 is equal to 2 meter per second square. And we can also write now a2. a2 is equal to twice a1, which is equal to 4 meter per second square. So we found out the acceleration of and tension for both the blocks. Next we have second question. Okay, which says that will the blocks move together? If yes, then find out their acceleration and tension in the string. If no, then also find out their acceleration and tension in the string. So we have two blocks, 2 kg and 4 kg. Between 2 and 4 there is a coefficient of friction of 0.5 connected by a string with a movable pulley, and there is fixed pulley connected with 5 kg, and there is no friction between 4 and the ground. Okay. So once again we are going to assume that it is moving towards right with the acceleration a. So there will be acceleration a of 5 kg in the downward direction. We have this as 50 Newton. So here tension, let it be T, and this will be T. So obviously we will have 2T, and this will be also 2T. So in this case we assume that both the blocks are moving with same acceleration. Say both blocks are moving with same acceleration. Therefore, we have acceleration of 2 kg is equal to A, and acceleration of 4 kg is also equal to A. So from here we can find out the acceleration of the pulley. Okay, we can say that let the acceleration of, let's call this pulley P, of pulley P is AP. Okay, so we can find out its acceleration. It is V pulley P connected with two blocks and with each having acceleration A. Then we can say VP will be equal to the summation and divided by 2, which means VP will be having acceleration A. So if VP is having acceleration A, then our 5 kg will be also having acceleration A. This implies that acceleration of 5 kg will also be A. Okay. And let us solve it one by one for the free body diagram. Okay, for block of 5 kg, we have, so 5 kg, downward is 50 and upward we have 2t, and it is moving in downward direction with the acceleration of A. You can see the 50 minus 2t is equal to 5A. Let us call this equation number 1. And we consider the combined motion of 2 and 4 kg. Okay. For combined motion of 2 kg and 4 kg block, so we have, this is 2 plus 4, and we have a tension T. This will be T, okay, and it is moving towards right with the acceleration A. So we clearly can say that 2t will be equal to 6A, and from here we can say that t is equal to 3A. So from equation 1 we have 50 minus 2t is equal to 5A. Substituting value of 2t as 6A, we get 50 minus 6A 5A, or A will be equal to 50 divided by 11 meter per second square. And we can find out tension T. T was equal to 3A, and this comes 3 into 50 divided by 11. You can say T will be equal to 150 divided by 11 newtons. Okay. And let us see whether these values will be possible or not. What we do, first of all, find out for the 2 kg and 4 kg. Okay. So what we assume, we say let no friction between 2 kg and 4 kg block. This will help us in order to find out the various forces which will be acting on it. Okay. So this will be helping us to find the direction of friction. Find out direction of friction. So if there is no friction, okay, so 2 kg we can add for 2 kg. This 2 kg, it is traveling with the acceleration a, and we have a force of T, and T came out as 150 by 11. We can say that A2 will be equal to our 150 divided by 11 into half. So we get A2 is equal to 75 divided by 2. And similarly for 4 kg, same 4 kg, and it is also having a 150 divided by 11 and traveling with the acceleration towards right. You can see that the acceleration of 4 kg is A4, which is equal to 150 divided by 11 into 1 by 4. From here you can see that A4 is equal to 75 divided by 22. So if you make comparison between A2 and A4, you can see that value of A2 is greater than value of A4. A2 is greater than A4. Sorry, here it will be 11. So A2 is greater than A4. So it means A2 will be traveling faster as compared to 4 kg block. So you can say that 2 kg block will travel faster than 4 kg block. Okay. So it means this is our 2 kg block and it will be traveling faster. So this will be making sure that it pulls the 4 kg block with as there is friction between these two, and let us call that as 4 is Fr, and accordingly there will be opposite force Fr here also. So we got the direction of a friction force, and we can find out that our Fr maximum friction force will be equal to coefficient is given as 0.5 and the normal will be 20 Newton for 2 kg block. Okay. Here it will be 20 and here will be normal, which is equal to 20. So this will be coming as 10 Newton. So it means if both the blocks to move simultaneously, the friction should be at least 10 Newton. Okay. You can say that for both blocks to move together, maximum friction is 10 Newton, and we are going to find out whether this friction is present or not. Okay. So we use for 2 kg block. Okay. So we have a force of T, and let us suppose this is Fr, and this is 2 kg block, acceleration in this direction. So we can write the equation as T minus Fr is equal to 2A. So from here we get our Fr is equal to T minus 2A. Value of tension T we already know is 150 by 11 minus, and our acceleration was, where it went, yeah, acceleration was, A was 50 upon 11, so this is will be 2 into 50 upon 11, so this will be 150 minus 11 minus 100 divided by 11, which will be equal to 50 by 11. So it means the value of Fr is less than our Fr max. It means required friction is less than maximum friction. So both will move together with acceleration of A, which is equal to 50 by 11 meter per second square. And find out the value of tension also. So we already know equation, and yeah, here it is. Okay. So tension, let us call this as tension. We get T will be coming as 150 by 11, okay, and for the string connected with 5 kg, tension will be equal to 2T, that is equal to 2 into 150 divided by 11 equal to 2 into 150 by 11, and which will be equal to 300 by 11. So these were the value of the tension as well as acceleration for the respective block. And this is the question number 3, the last question for this. So in this case we are supposed to find out once again that the maximum value of force, so that both blocks move together. So we have a block of 4 kg. Here the friction is 0, and 2 kg block is having a friction of 0.5, and the force is being applied with the help of this pulley towards the right side. So we are going to find out that both blocks move together. So let us assume that let both blocks move together with acceleration A. Okay, that means both are moving with the acceleration of A. Then we have that our F, therefore F will be equal to total weight is 6 kg and multiply by A. Okay. Now from here we can say that our acceleration will be equal to F by 6 if they are moving together. Okay. So it means the maximum acceleration will be also your F by 6. From here we can say the maximum acceleration which is represented by A max will be also equal to A, and which is equal to F by 6. So now let us assume that as it is a 2-block system and we are going to find out whether this condition is feasible or not. So we say that there is no friction between 2 kg and 4 kg. Okay. So assuming, okay, so let there is no friction between 2 kg and 4 kg. Okay. So let us draw this. So we have our 2 kg and we have our 4 kg, and 2 kg is being connected to the string, so here value will be F. Okay. So this will try to move 4 kg towards left, and accordingly there will be Fr towards right. Okay. You can say that force F, okay, here tension is equal to force because here F is tension is represented by force. So here also we did the same thing. You can say that the force F will try to move 2 kg towards left. Okay. Therefore, the friction between 2 and 4 will also force 4 kg movers toward left. Therefore, frictional force between 2 kg and 4 kg will try to move 4 kg towards left, and accordingly there will be force acting in opposite direction at 2 kg. Now let us draw the free body diagram for 2 kg. We consider for 2 kg. So we have this as 2 kg. We have a force F. We have our Fr. There will be 20 Newton, and in normal, which is also equal to 20, and we have acceleration A, which is A max, acting in this direction. So as the acceleration is towards right, so it is obvious that the force that will be responsible for maximum acceleration, that is A max, will be Fr. Okay. So we can write this as max, Fr max minus F will be equal to, and the acceleration is F by 6, okay, will be equal to 2 into F by 6, and here we can find out our Fr max. Friction is given as 0.5, normal is 20, and so this will be coming as 10 Newton. from here we can say that our Fr max will be equal to, we are going to find out the required value of my mistake. So Fr will be equal to, this will be F by 3 plus F, so it should be becoming 4F by 3. Okay. And now we make a comparison that it has said that the maximum value of force. Okay, so we can say that for F is equal to F max, we get Fr will be equal to Fr max. So you can say our Fr max is equal to 4F max by 3. So Fr max is 10, so this will be 10 is equal to 4F max by 3, and we find out that F max will be coming as 30 divided by 4, or which can be also written as 15 divided by 2 newtons. This is the value of the maximum force, so that the blocks will be moving towards right. Thank you.